So I have covered a series of few lectures and in which I covered in detail about the coordinate system, but this lecture is a summary lecture, and in this lecture you will find the equations of all the coordinates, that is the Cartesian coordinate, the cylindrical coordinate, and the spherical coordinate. So you will find equation of all these three coordinates here. Also the transformation equation, transformation from Cartesian to cylindrical, or whether it's from cylindrical coordinate to Cartesian, or from Cartesian to spherical and spherical to Cartesian. So this transformation is also covered. All the equation of the transformation is covered. So to start with, this video could be like 20 to 30 minutes or more. So you can skip if you are directly, if you what you are looking for is the equation of transformation, you can skip to after 10 minutes or so. But the initial lecture I will give all the equation of the three coordinates. So before we start, I have covered the derivation and in detail about all the coordinates in the previous lecture. So if you had watched those lectures, you would be aware, or if you want more detailed information, you can go through the videos in my channel and you could get into detail. But saying about the three coordinate system, the Cartesian coordinate system, which I am for which I have written the equations. So you could verify these equations with your textbook, but this is just to, if in your textbook there is no summary given, so this is just to give you a summary of how all the equations could be stacked up together, or how they relate to each other together. So this is a Cartesian coordinate system, which is a first system, and this is a x, y, z. This is a way to represent the system, and the three coordinates will be x, y, and z here, and the unit vector in the three direction will be ay, az, and ax, and the point will in the Cartesian coordinate system will be represented by x, y, and z. And the next kind of system is what is known as the cylindrical system. So this is a cylindrical system, and in cylindrical system, if I say this is x, y, and z, then it's possible to represent a point using what is known as a cylinder with a radius of rho, a plane with a radius of plane with a angle of phi, and the z axis. So this is the angle phi plane, and this forms with the z axis. Wherever it will cut, you can find the point, and the radius it makes here is a radius of a cylinder. So this will form a circular cylinder if you draw it this way. So this is how a point is represented in cylindrical coordinates, and these are the convention x, y, z I am going to use for the Cartesian coordinate, and for cylindrical coordinate what I will be using is rho, which is a radius of the cylinder, and phi, which is the angle of the plane which the radius of the cylinder is making with the x axis, and z is the z axis. And the next kind of system is the cylindrical spherical system, and if I represent the same way x, y, and z, then you can say that it is represented the point in spherical system. So this was a cylindrical system, and this was a Cartesian system, and the point in the spherical system is represented by using three things. So the first thing is a sphere of a radius r, the second thing is a cone of a angle theta, and the last is a plane phi. So I will have a sphere of a radius r, and this sphere will be making a angle theta with the z axis, which is a cone, and the finally you have, when you are projecting the same to the x axis or xy plane, the point P, it will make an angle phi with a plane or with a plane which is going in this side, which is a phi plane. So this is how it is represented in the, so this was a Cartesian, this was the cylindrical, and this was the spherical system. So I will just stop here, and based on the derivations which I have done in this lecture, in the series of lectures so far, so you can go through the previous videos to find the detailed derivation, but I will sum up everything, all the coordinates. So first, writing for the Cartesian coordinate, it's possible to represent a point P using x, y and z. And if you are taking the same for the cylindrical system, then as you saw previously, the point was represented by rho, phi and z, and for the spherical system it was represented by, the point was represented by r, theta and phi. And now the next is how a vector is written, how to write a vector in the Cartesian system. So to write a vector in the Cartesian system, it could be written as A is equal to ax plus ay plus az. Next is the cylindrical system. So this is the first thing which, and this is the second thing, cylindrical system. You can write a vector as, so in cylindrical you can write it as A is equal to a rho plus a phi plus az. And in spherical, the same vector can be written, if you know the 3 points, as ar plus a theta plus a phi. So this is how we are writing the 3 vectors. So this was the first step, or the first series of equation. This was the second series of the equation. And after this, what we will look into is some of the what are the unit vectors. You know, the unit vectors are these. So the dot product of the unit vectors. So knowing about the dot product of the unit vectors in Cartesian system. So in Cartesian system, the dot product of ax dot ax is equal to ay dot ay is equal to az dot az is always 1, and ax dot ay is equal to ay dot az is equal to ax dot az is equal to 0. So this is the same thing will also, so if you are taking about the dot products, so this was a dot product, this is the third thing which we are seeing. And if you are seeing for even the cylindrical system, you can say that the dot product of a rho dot a rho will be equal to 1, and similarly the dot product of a rho dot a phi will be equal to 0. And in same way, if you are taking for other, that is rho, phi and z, the 3 unit vectors, the same will follow. For the ones which are horizontal to each other will always, or ones which are at 90 degree to each other, that the a rho and a phi are 90 degree to each other, will always have a dot product equal to 0, because cos 90 is equal to 0. And the next is about the cross products. So if you are considering the cross product, what you will get is ax cross ay is equal to az, while ay cross az is equal to ax, and ax cross az is equal to ay. So this is how the cross product of the three unit products will look like. And in a similar way, if you are taking for the other coordinates like a cylindrical or spherical, the cross products of the vectors. So if you are taking for Cartesian coordinate system, it will be ax, ay or az, both will be 90 degrees. In a similar way, if you are taking for this, the ax and ay and az, arrow a phi and az will be always in 90 degrees. So all these coordinate system also will follow the same way for the cross products. So this was the third thing, and this was the fourth thing which we saw, how to write the cross products of all the three. And the next is how to write the dot product. So in Cartesian system, a dot b dot product of two vector can be written as ax bx plus ay by plus az bz. So this is for the Cartesian system. And the same will follow for the spherical system and cylindrical system. So finally what I will do is that I will now do the transformation. So the first transformation which I am doing is from Cartesian to cylindrical, or from cylindrical to Cartesian. So if you want to do this, this series of equation will be useful to you. So the rho can be written as, so a point, again, as you know, the point in the Cartesian will be written by x, y, z, and the point in the cylindrical will be written as rho, phi and z. So the rho in this case will be equal to under root x square plus y square, and the phi in this case will be is equal to tan inverse y by x, and z will be equal to z. So using this you can convert the value from the Cartesian to the cylindrical coordinate, and to convert it from cylindrical to Cartesian you need x is equal to rho cos phi and y is equal to rho sin phi and z is equal to z. So in this way, vice versa, you can convert it. And if you are converting the vectors, to convert the unit vectors, the formulas which we derived previously are a rho is equal to ax cos phi plus ay sin phi, and a phi equal to minus ax sin phi plus ay cos phi, and z is equal to az. So based on this you can convert the unit vectors from Cartesian to cylindrical. Again, from cylindrical to Cartesian, if you want to convert it, it is ax equal to a rho cos phi minus a phi sin phi, and ay is equal to a rho sin phi plus a rho cos phi, and az will be always equal to az. So this is how you can convert it from cylindrical to Cartesian when you know the unit vectors. And to convert the vector itself, vector components can be converted by this. The arrow can be converted as ax cos phi plus ay sin phi, and a phi can be converted as minus ax sin phi plus ay cos phi, and az is equal to az. So this is how you can convert the component vectors when you have from cylindrical Cartesian to cylindrical when you have the component vectors in Cartesian. And again finally, from cylindrical to Cartesian you can convert it as ax is equal to a rho cos phi plus minus a phi sin phi, and ay is equal to a rho sin phi plus a phi cos phi, and az is equal to az. So this is how you are converting it from cylindrical components to Cartesian. So these are the basic equations of. So in this sheet I have listed down all the basic equations which you will be ever needing to convert from Cartesian to cylindrical or from cylindrical to Cartesian. So whichever is given to you, you can convert to the other side using these equations. So in the next I will cover about how to convert from Cartesian to spherical coordinates. So this video is about how to convert from Cartesian to spherical coordinate system, or from spherical to Cartesian system. So a point in the Cartesian system will be given by x, y, z, and a point in the spherical system can be given by r, theta and phi, which we have seen. So how to convert from these two? So the first thing is that you can convert the radius r as x square plus y square plus z square under root. Then you can convert the theta is equal to tan inverse of under root x square plus y square divided by z square, and you can convert the angle phi is equal to tan inverse of y by x, and this is when you have the values in Cartesian system and you are converting to Cartesian system to spherical. And the next is if when you have it in spherical system, what you can do is you can convert it to x is equal to r sin theta cos phi and y equal to r sin theta sin phi, and z is equal to r cos theta. So this is how we are converting it from spherical to Cartesian system. So when you have that, when you have the values, now finally the next step is, this is the first steps. So next important series of equation is how you can represent the unit vectors. So to represent a unit vector, AR can be represented as AX of sine theta cos phi plus AY sine theta sine phi plus AZ cos theta. And A theta unit vector can be represented as AX cos theta cos phi plus AY cos theta sin phi minus AZ sin theta. And A phi unit vector can be represented as minus AX sin phi plus AY cos phi. So this is how you are representing the three unit vectors. The next thing is to represent the vectors when they are given in the. So this is how to convert from when you know the values in the Cartesian system. So the Cartesian to spherical. Again, from spherical to Cartesian, how to convert it is when you know the values, you can convert AX is equal to AR sin theta cos phi plus A theta cos theta cos phi minus A phi sin phi, and AY is equal to AR sin theta sin phi plus A theta cos theta sin phi plus A theta A phi, not A phi cos phi. So you have to differentiate between theta and phi, and AZ is equal to AR cos theta minus A theta sin theta. So this is how you are converting it from the unit vectors from spherical to Cartesian. Now finally you will have to also convert the vectors. So when I am having a vector, to convert the components of each of the vector, the AR can be converted as AX sin theta cos phi plus AY sin theta sin phi plus AZ cos theta, and A theta can be converted as AX cos theta cos phi plus AY cos theta sin phi minus of AZ sin theta, and A phi can be written as minus AX sin phi plus AY cos phi. So this is how we are converting each of the components from Cartesian system to spherical system. And finally, if we are converting it for to spherical to Cartesian, the component, the values can be written as Ax is equal to AR sin theta cos phi plus A theta cos phi plus A phi sin phi, and AY can be converted as AR sin theta sin phi plus A theta cos theta sin phi plus A phi cos phi, and AZ is equal to AR cos theta minus A theta sin theta. So this is how you are converting it from Cartesian or from spherical to Cartesian. So what I want to show you through is that these are the conversion or the transformation equations for to do the conversion. So again, these are the values which you will be ever needing. So this is a bigger picture. So this is so if you are doing the conversion, so these values are correct to my information, but again it could be better to cross validate with your textbooks. But this is all the information which you will be needing if in terms of the vector calculus, which you will be needing to solve the problems related to the electromagnetics. Again, what you will need is you will need information about the basic equations of the curl, the gradients, etc. So that's just one step, and again the line integrals, etc. So which I have already covered in the previous lectures, but I will be covering a series of few more lectures if possible in this series to complete the electromagnetics and cover the important topics related to this.